Chapter 6 Energy, Temperature, and Heat. Section 6.2 Measurement of Surface Air Temperature. So meteorologists measure temperature at weather stations routinely. This information is very important. Temperature has an important influence on our life for things like agriculture or whether or not we have to dress warmly because the weather's cold. When meteorologists measure temperature, they measure it with particular instruments, and the methodology they use is standardized. Now, temperature can be measured with a simple thermometer, and the most common design that's available is liquid in glass. So what it is basically a glass tube filled with some kind of liquid. And two liquids are commonly used, mercury and alcohol. The two most common scales used for measuring temperature with a thermometer are Celsius and Fahrenheit. And Celsius is of course common in Canada, Fahrenheit more common in the United States. So here is a comparison of the Fahrenheit and Celsius temperature scales. It's very easy to convert between each other. A simple mathematical formula. So on here I've listed some interesting temperatures related to thermometers. Boiling water occurs at 100 degrees Celsius or 212 degrees Fahrenheit. The highest temperature ever measured on our planet occurred in Libya, 58 degrees Celsius, 136 degrees Fahrenheit. Highest temperature in North America, Death Valley, California, at 57 degrees Celsius or 134 degrees Fahrenheit. In the Okanagan and Kelowna, we can get temperatures in the high 30s quite often in the summertime. Room temperature is somewhere between 18 and 23, 24 degrees Celsius. The temperature of the freezing point of water, temperature at which water freezes, is 0 degrees Celsius or 32 degrees Fahrenheit. Mercury thermometers are not used for measuring temperatures that go too cold. Mercury freezes at minus 39 degrees Celsius. So instead, when we measure very, very cold temperatures, alcohol thermometers are used. Lowest temperature ever measured in North America, Snag, Yukon, Canada, minus 63 degrees Celsius or minus 81.4 degrees Fahrenheit. Lowest temperature in the world, Vostok, Antarctica, minus 89 degrees Celsius or minus 129 degrees Fahrenheit. Now the extremes in terms of cold and hot, they're likely to be broken in the future because our measurements are the density of measuring stations in both the coldest parts of the world and the hottest parts of the world are few and far between. So here are examples of maximum and minimum thermometers. These are thermometers that are housed in something called an instrument shelter or a Stephenson screen. The thermometer on the top is our minimum thermometer. I can tell that because the red liquid that's in there is alcohol. And in this thermometer, we have a slider, and the alcohol, when it decreases in volume due to colder temperatures, moves that slider down, and then we measure the minimum temperature from the top of the slider. So we don't have to be there when the slider reaches the coldest temperature. If it warms up after that, the slider stays put. The mercury thermometer below is for measuring maximum temperatures. It's got a constriction just above the bulb where most of the mercury is stored. As the mercury moves up, it moves up with the expansion of the mercury due to temperature. And what happens is when it reaches its maximum temperature, it doesn't go back down because there's a small constriction just before the top of the bulb, and and surface tension of the mercury stops it from flowing back into the bulb. The way that you get that mercury back in the bulb or reset it is you shake it, and you shake it to reset it, and then it can be used to measure another maximum temperature. Both of these thermometers, they're designed so that they can be left alone for a 24-hour period, a usual 1 day from midnight, just after midnight to just before midnight during the day, and their design allows us to capture the temperatures that occur during that period. As I said, these instruments are housed in something called an instrument shelter. These instrument shelters are designed all in the same way, and they house other instruments too, besides just instruments to measure temperature. The reason why we use a standardized shelter is we want the measurements to be measured in the same way. We don't want them to be measured in bright sunlight, which would influence the temperature of the thermometer. We want these instrument shelters to hold the thermometers at a particular distance above the Earth's surface. So this standardization makes sure that data can be used for things like modeling and forecasting. Even the thermometers are calibrated. These thermometers are only built or made in certain companies, and the companies make sure that they're properly calibrated so that they come out of the factory all measuring temperature in the same way. So as I said, these instrument shelters are sometimes called Stephenson screens. Now that's where analog instruments are kept. What's becoming common now is a different kind of instrument shelter called a maximum minimum temperature system, and this is something used to measure or to house digital thermistor for measuring temperature, a digital instrument. And it's a much smaller sort of shelter or box where the instrument is held in. So up top is a Stephenson screen, 2 of them. This is at the airport. No, sorry, not at the airport. When the meteorological station used to be just on our campus, and below is a maximum minimum temperature system shelter. So in there aren't liquid in glass thermometers. It's a digital instrument using a thermistor to determine temperature. Let's look at some of the usual values we calculate from these measurements. And these things that we calculate, we can call them statistics, or means, ranges. We calculate out normals or extremes. A daily mean temperature is equal to the maximum temperature plus the minimum temperature divided by 2. That's the daily mean temperature. Daily temperature range is a measurement of the difference between the maximum and minimum temperature, so we go max minus min. If we want to figure out the monthly mean temperature, we sum all the daily means and divide it by the number of days in the month. So here this graphic illustrates the concept of mean temperature. So if we had a maximum of 30 and a minimum of 0, 30 plus 0 divided by 2 equals a mean temperature of 15. We can also figure out from this the daily temperature range, which would be 30 minus 0 or 30 degrees. Annual mean temperature is the average of all 12 monthly means. Annual temperature range is the difference between the warmest and the coldest month. A meteorological normal is an average of some meteorological element, like temperature or precipitation, over a period of time. and the preferred time period for meteorological uses is 30 years. And the normals move every 10 years. So for example, if we were measuring temperature, let's say in the 1990s, like 1992, we would use the normal from 1961 to 1990 as a standard. In 2021, we'll use the temperature normal from 1991 to 2020. For this year, for 2020, we use, for comparison purposes, we use a normal 30-year period from 1981 to 2010. A meteorological extreme is the highest or lowest value of some meteorological element over a period of time. So what was the highest temperature recorded, let's say, during this during the last normal period, 1981 to 2020? Or if we have data that goes back longer than the last normal period, we might measure this meteorologic extreme from the beginning of the recordings at that particular station. So here we can see a graph of monthly mean temperatures. There's the normals, and then plotted on here is the extreme high, for a particular period of time, whether it's 30 years or more, and the extreme low recorded for those particular months, whether it's January, February, March, or any of the others.